Preparing for the Washington State HVAC/R Limited Energy Administrator's License exam requires a strategic approach. Several methods can enhance your learning and increase your chances of success. Firstly, consider enrolling in online courses or programs specifically designed for this exam. These programs offer structured learning modules, practice tests, and expert guidance, providing a comprehensive learning experience. Secondly, join study groups with other aspiring licensees. Discuss concepts, solve problems together, and support each other's learning. Collaborative learning can be highly effective. Consider hiring a tutor to provide personalized guidance and clarification on difficult topics. Thirdly, practice exams are crucial. Take multiple practice exams to familiarize yourself with the exam format, question types, and testing time constraints. Analyze your performance on these exams to identify areas where you need improvement. Focus your studies on those specific topics. Fourthly, if possible, gain practical experience by working alongside experienced HVAC/R technicians. Hands-on application can reinforce theoretical concepts and enhance your understanding. Practical experience is invaluable. Fifthly, dedicate time to studying the codebooks thoroughly. Use resources like the firm's Fast Finder to quickly navigate and locate relevant information. Refer to codebook examples and diagrams to reinforce your understanding of code requirements. Sixthly, create flashcards or summaries of key concepts, formulas, and code rules. Regularly review these materials to retain information and improve recall speed. Flashcards are a great tool for memorization. Seventhly, identify the specific topics covered on the exam using the test blueprint. Prioritize your studying accordingly, focusing on the areas that are most heavily weighted on the exam. Eighthly, establish a realistic study schedule that allows ample time for learning, practice, and review. Break down large sections into smaller chunks for easier comprehension. Time management is essential for effective exam preparation. Additionally, stay organized by using binders or folders to store study materials, notes, and practice exams. A well-organized study environment promotes efficiency. Do not hesitate to reach out to instructors, tutors, or peers for clarification or support. Asking for help is a sign of strength, not weakness. Maintain a positive attitude and believe in your abilities. Preparing for exams can be challenging, but a positive mindset can make a significant difference. Get enough rest, as sleep is crucial for cognitive function and memory retention. Adequate sleep improves your ability to learn and recall information. On the day of the exam, arrive early, stay calm, and focus on answering questions one at a time. Proper test-taking strategies can help you perform your best. Remember to review all relevant sections of the 2017 National Electrical Code, or NEC, as it is often referred to. Understanding the basic electrical theory is essential for the exam. This includes concepts such as voltage, current, resistance, and power. Ohm's law, which states that voltage equals current times resistance, is a fundamental principle. Knowing how to calculate voltage drops in circuits is also important. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. It's essential to ensure that the voltage at the equipment is within the acceptable range for proper operation. Conductors must be sized properly to prevent excessive voltage drop. NEC Section 210.19 A1 states the feeder conductors shall be sized to carry not less than the calculated load. The allowable voltage drop for feeders and branch circuits should not exceed 3%, and the total voltage drop on both feeder and branch circuit to the farthest outlet should not exceed 5%. Understanding grounding and bonding is critical for safety. Grounding provides a path for fault current to return to the source, allowing overcurrent devices to operate and clear the fault. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. NEC Article 250 covers grounding and bonding requirements. NEC Section 250.4 A5 requires that normally non-current carrying conductive materials enclosing electrical conductors or equipment or forming a part of such equipment shall be connected together into the electrical supply source in a manner that establishes an effective ground fault current path. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. Understanding how these devices operate and how to select the appropriate size for a given circuit is crucial. NEC Article 240 covers overcurrent protection. NEC Section 240.4 D specifies restrictions on overcurrent protection for conductors. Commonly used wiring methods include non-metallic sheath cable or NM cable, electrical metallic tubing or INT, and rigid metal conduit or RMC. Each wiring method has its own set of requirements for installation and support. NEC Chapter 3 covers wiring methods and materials. In HVAC/R systems, motors are used to drive fans, compressors, and pumps. Understanding motor control circuits, including starters, overload relays, and control transformers, is essential. NEC Article 430 covers motors, motor circuits, and controllers. Control transformers are used to step down the voltage to a low level for control circuits. Understanding how to size and protect control transformers is important. NEC Article 450 covers transformers. Understanding the different types of HVAC/R equipment, such as air conditioners, heat pumps, and refrigeration systems, is crucial. Familiarize yourself with the components of these systems, including compressors, condensers, evaporators, and metering devices. Refrigerant is the working fluid in HVAC/R systems. Understanding the properties of different refrigerants, as well as the regulations governing their use and disposal, is essential. The EPA has regulations concerning the use and disposal of refrigerants. Ductwork is used to distribute air in HVAC systems. Understanding duct sizing, materials, and installation practices is important. The International Mechanical Code, or IMC, provides requirements for ductwork. Combustion appliances, such as furnaces and boilers, use fuel to generate heat. Understanding combustion safety, including venting requirements and carbon monoxide detection, is critical. The International Fuel Gas Code, or IFC, provides requirements for combustion appliances. Building codes, such as the International Building Code, or IBC, address structural and safety requirements for buildings. Understanding these codes is important for ensuring that HVAC/R systems are installed safely and in compliance with regulations. Review the Washington Administrative Code, or WAC, which contains the state's regulations for HVAC/R systems. The WAC provides specific requirements for licensing, permitting, and inspections. Become familiar with the various standards organizations that develop standards for HVAC/R equipment and systems, such as the American Society of Heating, Refrigerating and Air Conditioning Engineers, or ASHRAE, and Underwriters Laboratories, or UL. These standards provide guidance for the design, installation, and operation of HVAC/R systems. Calculations are an important part of HVAC/R work. Be prepared to perform calculations for load estimation, duct sizing, and electrical circuit design. Review basic math and algebra skills to ensure that you can perform these calculations accurately. Safety is paramount in HVAC/R work. Always follow safety procedures and wear appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and hearing protection. Be aware of potential hazards, such as electrical shock, refrigerant leaks, and falls. Understanding the principles of thermodynamics is essential for understanding how HVAC/R systems operate. Review the basic laws of thermodynamics, including the first law, second law, and third law. Familiarize yourself with the different types of heat transfer, including conduction, convection, and radiation. Psychometrics is the study of the properties of moist air. Understanding psychometric charts and calculations is important for designing and analyzing HVAC systems. Airflow measurement is used to determine the amount of air flowing through a duct or system. Understanding the different methods of airflow measurement, such as pitot tubes and anemometers, is important. Balancing is the process of adjusting airflow in a duct system to ensure that each space receives the proper amount of air. Understanding the principles of air balancing is important for optimizing system performance. Controls are used to regulate the operation of HVAC/R systems. Understanding the different types of controls, such as thermostats, dampers, and valves, is important. Troubleshooting is the process of identifying and resolving problems in HVAC/R systems. Develop strong troubleshooting skills by practicing on real equipment and studying troubleshooting guides. Stay up to date with the latest technologies and trends in the HVAC/R industry. Attend training seminars, read trade publications, and participate in online forums to expand your knowledge. Consider joining a professional organization such as ASHRI to network with other HVAC/R professionals and access valuable resources. Networking can provide opportunities for learning and career advancement. When studying the NEC, pay close attention to conductor ampacity. NEC Table 310.15. B16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in raceway, cable, or earth, based on ambient temperature of 30 degrees Celsius. Correction factors are needed if the ambient temperature is higher. Derating factors apply when more than 3 current carrying conductors are in a raceway. NEC Section 310.15. C1 states that where the number of current carrying conductors in a raceway or cable exceeds 3, or where single conductors or multi-conductor cables are installed without maintaining spacing for a continuous length longer than 24 inches, the allowable ampacity of each conductor shall be reduced. Familiarize yourself with the wiring requirements for specific equipment. For example, NEC Section 440.31 covers the marking on a controller that employs solid-state components for reduced voltage starting of air conditioning and refrigeration equipment. Article 430 covers motors, motor circuits, and controllers, and has specific requirements for motor protection and control circuits. Remember to study the definitions in NEC Article 100, as they are critical for understanding the code. Knowing the definitions of terms like ampacity, grounded, bonded, and overcurrent is essential for proper application of the code. Use online resources, such as the NEC website and various electrical forums, to supplement your learning. There are many online tools and resources available to help you understand the code. Practice applying the code to real-world scenarios. Work through examples and case studies to develop your understanding of how the code applies in different situations. Seek out opportunities to work with experienced electricians and HVAC/R technicians. Hands-on experience is invaluable for learning the trade and applying the code. Participate in continuing education courses to stay up to date with changes to the NEC and other relevant codes and standards. The electrical and HVAC/R industries are constantly evolving, so it's important to stay current with the latest development. When calculating branch circuit loads, be sure to account for all of the loads that will be connected to the circuit. NEC Section 220.12 covers general lighting loads and provides minimum lighting loads for various occupancies. NEC Section 220.14 covers other loads such as receptacle outlets and appliance loads. When sizing service conductors, be sure to account for all of the loads that will be connected to the service. NEC Article 230 covers services and provides requirements for service conductors, overcurrent protection and grounding. Understand the requirements for emergency systems and standby systems. NEC Article 700 covers emergency systems, and NEC Article 701 covers legally required standby systems. These systems are designed to provide power to essential loads during a power outage. Be familiar with the requirements for hazardous locations. NEC Articles 500 through 516 cover hazardous locations and provide requirements for electrical equipment and wiring in these locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Remember to review the NEC frequently and thoroughly. The NEC is a complex document, and it's important to review it regularly to ensure that you understand the requirements. Don't be afraid to ask questions. If you're not sure about something, ask an experienced electrician or HVAC/R technician for clarification. Review the administrative rules for Washington State. These rules outline the requirements for licensing, permitting, and inspections. Understand the different types of licenses available in Washington State and the requirements for each license. Ensure that you meet the eligibility requirements for the license you are seeking. Complete the application form accurately and submit it with all required documentation. Pay the required application fee. Schedule your exam at a convenient location and time. Arrive at the exam location early and be prepared to show identification. Follow the instructions of the exam proctor. Answer all questions carefully and to the best of your ability. Review your answers before submitting the exam. Once you have passed the exam, you will be issued a license. Keep your license current by completing continuing education requirements. Comply with all applicable laws and regulations. Conduct your business in a professional and ethical manner. Provide quality services to your customers. Maintain adequate insurance coverage. Protect the health and safety of your employees and the public. Stay informed about changes in the industry. Continuously improve your skills and knowledge. Seek out opportunities for professional development. Be a responsible member of the HVAC/R community.